So, yeah, today we're going to be going over 2D lists. As you can see over here, 2D lists are a direct extension of one-dimensional lists and of list comprehension. So we know that there are three important things that we need to learn about 2D lists. We need to learn what they are like compared to one-dimensional lists, how to create them with list comprehension, and also what they are supposed to be used for. So we'll cover these topics in chronological order. So over here you can see the actual structure of a 2D list compared to the structure of a 1D list. So you guys learned about 1D lists, right? This is what a 1D list looks like, and this is what a 2D list looks like. So 2D lists are called 2D lists merely because inside of one list you have smaller lists. So it's just a list inside of a list. And of course, in the smallest of these lists, you can put like all kinds of stuff, strings, booleans, and of course here I have numbers. And they don't have to be ordered this way. And so they don't have to be like 1, 2, 2, 3, 3, 4. No, you can like put whatever you want in these smaller lists in whatever order, and like the size can always be different. And in 2D lists, there are two types. There's like jagged and then like not jagged. So this is not a jagged 2D list because every single list inside of the biggest list is of size 2. But jagged lists are basically when, say, this list, if it had like one more element or one less element than the others. But usually you'll be dealing with non-jagged lists because you usually use 2D lists to model like grids and tables, and usually those things are pretty nice and even. So in order to declare a 2D list, there's about two ways to do it. You can do it using list comprehension, or you can do it the way that I've done here, which is just typing it like setting a variable equal to, and then this list. So also, if you want to get like a certain element from a list, you need to give first the index of the smaller list that's inside the biggest list, and then follow up that index with the index of the element that you want to get in the smaller list that you're looking at. So if you had like put all of this code into like into like a Python file and you ran it, then for this one you get the computer would print out 2, so it would print out this element, and if you ran this, the program would print out the number 3, because as we all know, indexes start at 0. So basically what you're telling the program to do right over here is to go to the first list inside the bigger list, and then look at the element at index 1, which is this over here, and then the same thing for the second one, but like of course different indexes. So can anyone tell me like what the indexes you need to put into? Like what indexes would you need to put into 2D in order to access this number 5? So like does anyone know so we'd call this like 2D at 0, at 1. So what are the two numbers you need to access this number over here?
4 and 1.
Yeah. Wait, no, sorry, 3 and 1, yeah.
3 and 1.
Yeah, exactly. So, and of course, as always, when you put those numbers in, you just follow this format where you have the name of the variable followed by a square bracket, like the index of the smaller list, another closing square bracket, and then 2 more square brackets with the index of the element that you want inside of that smaller list. Okay, so yeah, so now we'll be talking about creating 2D lists with list comprehension. So you can always, of course, do it this way, but this is very inefficient. It takes a lot of time, and sometimes like you might end up messing up, like you might add one too many of a bracket, or like you might forget a comma, and it's very time consuming, right? But I mean, this can be kind of useful if you like just want to create a 2D list and like always work off of that. But if you're taking in input, then you don't want to do it this way. So if you want to create lists, 2D lists with list comprehension, then it's kind of a direct extension of just creating a normal 1D list using list comprehension. So as is the case with like most things involving 2D lists, it's just nesting a smaller list inside of a bigger list. But this time it's just nesting like a smaller list comprehension inside of a bigger list comprehension. So you guys learned about list comprehension last time, right? Did you guys learn about list comprehension last time?
Yeah, we did.
Okay, great. So then, so this part that I'm highlighting should be pretty familiar, right? You just have like the two square brackets, and then inside you have for I in range 4. This means that this is almost like order of operations. Yeah, so you can think of it in that way, and basically you work from the inside out. So first, you have this. So this is just straight up a normal list comprehension. So you basically create 5 like dot strings with 1 dot inside, and then after that, the program moves on to what's on the outside even more. So then you do this entire list comprehension, and basically what that's doing is it's taking the list of 5 dots that you created over here, and then just doing the same thing 4 times over. So over here you can kind of see basically the structure, or like the dimensions of the list, of the 2D list that you're creating. So you have to keep in mind though that the dimensions of the thing is something that is like 5 across from left to right, and only 4 from top to bottom. So that can be pretty important to remember, because in some computer science problems, you need to create like a grid that's like a certain number of columns and a certain number of rows big, and you don't want to like mess up these two numbers. Otherwise, your grid's going to be off, and you might be trying to access parts of the 2D list that don't exist. So this creates something that's 5 by 4. Well, 5 columns and 4 rows. Also, when you end up accessing something inside of a 2D list, the group of numbers that you use to access that element might remind you of an ordered pair, but they are slightly different to an ordered pair, because an ordered pair goes x and y. So first, so in an ordered pair, if you like relate that to like a Cartesian grid, if you put in like the ordered pair like 1, 4, then basically that's telling that's directing you to a point on the grid that's 1 to the right, and then 4 up. But when it comes to these 2D lists, it's more like it's more of yx. So first you're choosing like how far down you go, and then you choose how far to the right you go. And the reason why is just because of the structure, because as we can see going back over here, the first thing that you access, or the first index that you give, will always return you like the list that's inside of the biggest list, and that just relates to like the height. And finally, when you do the second index, that just gives you the thing inside the smaller list, which relates to left and right. If we were to say try and access this dot over here on the bottom right hand corner, well, first of all, the first number in the ordered pair for a 2D list actually relates to how far down you go. So if you put in like 2D at 0, at 1, you'd get this, so just this dot. And if you did like a 2D at 3, then you'd get all of the dots here. But if you did 2D at 3 at 4, then you would get this dot at the bottom right hand corner. So yeah, like related to like normal grids in math, a 2D list. First, you have the x and y coordinates basically flipped around, and then secondly, you also have like the y coordinate talking about how far you go down instead of how far you go up. But other than that, they're pretty similar, and you can use them in similar ways to like plot or to figure out like direction and like movement. So I just want you guys to like if you haven't already, like run this code. Like you can copy and paste it into a Python shell, and then with that code you can run it, and then and just keep in mind that whenever you're declaring a 2D list using list comprehension, it's always going to be something like this. And of course you can change the variable name, but the overall structure will always be the same. Of course, like these numbers in the ranges might change. Like if you want a 2D list that has like maybe 6 or 7 columns, and of course you change this number. If you want a difference in like the number of rows, or then you'd change this number over here. And of course, finally, just this is the thing that's going to be added into the list. So keeping it as like a string will just create a 2D list of a bunch of strings. And if you have a number, you can have a 2D list of a bunch of zeros, and that's pretty useful when you get into like dynamic programming and stuff like that. All right, so now we've talked about creating 2D lists, and we've also talked about like their overall structure. But when it comes to actually printing out a 2D list, which is pretty important, especially if you want to like check over your code while you're doing a contest problem. When it comes to printing out a 2D list in this case, sometimes it can be kind of difficult, and also you might end up, well, I mean, you should probably just try it, right? Because over here I have a piece of code for creating a 2D list, and this is also an example of how to create a 2D list where like not all the elements in the list are the exact same. So with this code, I think you should be able to create like a 2D list that's got like 10 columns, 8 rows, and in every single row, the numbers will go from like 1 to 9. So yeah, like there'll be different elements. But if you actually try and just print this 2D list, then what you're going to get is just basically something very similar to what we have here. So although like 2D lists printed in this form can kind of give you a good idea of why 2D lists are called 2D lists and like their overall structure, they're not very useful if you're trying to do a question that involves creating a grid or creating a table. So, and more often than not, you'll need to create a table or grid with a 2D list, and it'll just be in general just better to have them printed in like table or grid form. But the normal printing of a 2D list won't give you that. Instead, you have to like import pprint, which is like a Python module. So whenever you're working with 2D lists, if you think you're going to need to like get like see your 2D list visually, then you'll want to add import pprint to the very top of your program. And then when you actually do print your 2D list, instead of just doing print, you should do pprint.pprint, which will allow your program to print out the 2D list in a grid form. Now, the thing is, this does have like a few limitations, because if you try and do pprint of like a grid, of a 2D list that is like 3 by 3, then it won't actually print it in a grid form, because like that's like too small for the I guess the module to handle. But that doesn't really matter, because 3 by 3, that's just like 9 elements in total, so it's not too complicated, and that's not too much of a drawback. The important thing is that say if you want to see like the structure of a 2D list like this, you can use pprint and you'll be able to see the structure. So like if you haven't done so already, just like I guess copy and paste this code into your Python shell and run it, and you can get a sense of how much easier it is to see what's going on in a 2D list and to see the patterns in it using pprint.pprint as opposed to just using print. So with 2D lists, there are also certain problems, and like this problem also applies to lists in general. So over here we have like, so there are some cases when you're doing computer science problems where you might want to have like two versions of the same thing, or to like create a temporary copy. There are a lot of questions later on in computer science where, say, you want to like do the same task but differently, and you always want to, go off of like the same start point, but you might end up doing different things to like the same piece of data over time. And of course, if you're gonna do something to like a variable or to a list, you want to have a copy of that original list if you're going to need to, say, do things all over again. You don't want to have to like reverse the process as you did, which is really inefficient. So there are times when you do need two copies of the same list. But the thing with Python is if you just declare a list, and this can be a 2D list, a 3D list, or even a 1D list as shown here. It doesn't really matter, but any list, if you just simply name a variable and set it to just that list like this, and you do anything to the original list, then if you print the copy of the copy of the list will also have changed, right? So like this might not be as clear if I'm just talking about this. So okay, so apparently the copy and pasting doesn't work. So instead, I'll just create the what I typed up. So anyways, here we have the original list. We can create a copy of that by setting b as a, and then we can append a value to a. So in this case, we can just append like 9, and then if we print a, of course, it should be 1, 2, 3, 4, 5, 9, as it shows there. But at the same time, if you print b, now we copied b over here right after we created a and before we appended 9. So if we print b and b was like an actual copy, then it should just be 1, 2, 3, 4, 5. But when we print it here, it's also 1, 2, 3, 4, 5, 9, which shows that like b and a are kind of like connected together at this point. So b isn't like an individual copy, and changes made to a will also affect b. So that's not really what we want, because if we want b to be like a record of what a was originally, then that's kind of we kind of failed in that department, because now b is the same as a, right? So we don't want that. The funny thing to note here is that if you have like c equal to 6, and if you set d as equal to c, and you increment c, then d will still be at 6, but c will not, because c will have grown. When you're dealing with, I guess, more simple data types like strings and integers, and you copy them like by just using an equal sign, then it will be like a individual copy, and changing the original will not change the copy itself. So that's a good thing. But when it does come to lists, we don't want that, and we want b to not be changed when you change a. So the real question is like, how do we go about that? And to fix this problem, we use this. So, well, first I'll show you guys how it's what it's like. So if you just add these two square brackets and put a colon inside. Oh, I didn't print anything. Print b. Then 9 shouldn't be added to the end. And yeah, 9 isn't added to the end. So by just adding, well, these 3 characters, you can make it so that b is a different copy. And we call this a deep copy, which means that, so a shallow copy is when basically a shallow copy of a would be this. So changing a changes b, and a deep copy will be this, and changing a does not change b. And this is what we want, and it's usually more useful to have things this way. So yeah, but these 3 characters, what they're basically saying is they kind of work off like the principles of indexes. So we know that like if you did like a at 0, right, and you printed it, well, you would get a 1, because that's the element at the first index. So and you guys should have learned also how to like access like certain things in an index, but also how to access like a range of things in an index. So if I wanted to say access 2 and 3, I would do 1 colon 3. So, and of course, this stuff is the first number is inclusive, the second number is exclusive. So you start at index 1, you go to index 2, and then you don't go to index 3. And that's usually how ranges work in general. Like they start at the first number and they go up to, but they don't actually reach the second number. In this case, if you print B, then it should be just 2, 3. Yeah, a list of the numbers 2 and 3. So in this case, when we just set both of these as empty, then what we're telling the program to do is, hey, I want to access everything from the beginning to the end, and that's why I want B to be. And that just happens to be a way of creating a deep copy of A. And also, when you use a colon like this and you want to access like a range of things in a list, yeah, it's inclusive of the first number, it's exclusive of the last number. So technically, if you left this thing empty, that's the same as having 0 and then going up to 6. Yeah. Oh, sorry, 5. Yeah. So this would yield about the same result. So yeah. And it's okay if your second element is 1 bigger than like so like the greatest element that you can reach in this list, like if you put A and you put 5 in the square brackets, it throw an error because there is no fifth element or element at index of 5. But it is okay to have something like this, because as I said before, right, 5, you go up to it, but you don't actually reach it, so there is no error. You're not accessing anything out of bounds. And also, when you leave things blank, that's implying that you want to go. So when you leave the thing to the left of this colon blank, that's implying that you want to start from the very beginning. And when you leave the thing to the right blank, that's implying that you want to go to the very end of the list. And this can be useful sometimes when, say, you don't want to like find the length of the list, or when you're not exactly sure how big the list will get, but you just know that you want everything from a certain point to the very end, or from the beginning to a certain point. So yeah, that's how you deep copy a 1D list. But when it comes to a 2D list, well, you can't really do just this, and you're going to have to do a bit more than that. And it all comes down back to list comprehension, which I think you guys learned last week. And list comprehension is extremely important in relation to 2D lists, because that's how you create them, that's how you deep copy them, and sometimes that's how you like access them too. So yeah, we're going to go to deep copying 2D lists. So with the code over here, and I mean, yeah, it didn't work copy and pasting last time, so I'll just type it up, and yeah, we can go a bit slower, I guess. So we import pprint if we ever intend to like print out the 2D list and we want it to look nice, right? And then we do the list comprehension. So here we just do k plus 1 for k in range 10, and then we also do for I in range 8. And of course, like 10 and 8, these can really be any number whatsoever, but I just decided to choose 10 and 8, so you can change these numbers up if you want. So yeah, as always, this is the smaller of the list comprehensions. It's basically you take a complete list comprehension and you stuff it into a bigger list comprehension, and yeah, that's how you create that 2D list. So so we can see here that if you just print 2D like this, it's not going to look very pretty, and you can't, well, I mean, you can kind of see a pattern, but it doesn't look that nice, and the better way is just to do pprint.pprint, making use of the Python module that we imported, and then we get to see a nice grid, and yeah, it's very nice. So now the same thing with 1D lists also applies to 2D lists. If you just do say the different one is equal to 2D, right? And you do like 2D, say dot append 9, and you were to pprint dot pprint diff, then it would also have been changed just like 2D. So yeah, as you can see here, I just appended a extra 9 to the very end. Now this process, so this also kind of shows how you don't actually need you don't need every single element in a list to be the same, because if you think about it, oh yeah, right, because I pprint, first I pprint 2D, the original 2D, and then I pprint the diff, which has been changed alongside with 2D. So really we should just be looking at this 2D list, because this is the changed 2D. So yeah, as you can see, all of the elements, except for the last one, are lists themselves, but the last one is just an integer. So yeah, in Python, lists are very flexible, where you can put like a string inside, a boolean inside, a list with even more elements inside, and then an integer inside, and it all doesn't matter. Which is also why you can create like those jagged 2D lists where some lists inside the bigger list have like more elements than others. Okay, so and what I showed just now also shows that you know, diff has been changed alongside with 2D. So now we need to see how would we actually make it so that diff is a true copy of 2D, and changing 2D does not change diff. Well, I mean, once again, with 2D lists, we have to make use of list comprehension. So first we put in the 2 square brackets, and then we could put it 2 more square brackets on the inside, and where like my I guess cursor is, that's where we're gonna start like the smaller of the list comprehensions. So we just do oh wait, sorry, yeah, you do something like this. Well, I mean, sorry, for I in 2D. Right, and if you do it this way, then when you run the code, yeah, so this is the original 2D, this is diff, which is a copy of the original, and as you can see, this matches with the original, and it has not been changed, unlike 2D has. So like the explanation of this code is, once again, we're seeing like these 3 characters, right? The colon inside of the 2 square brackets, and that's once again saying, hey, I want my program to access every single element inside of a smaller list. And we do, so I here is a variable, so you're going for I in 2D. So when you do things like, so there are kind of 2 different ways to create a loop. There's like for I in variable or list, and then for I in range, and then like a certain number. When you do for I in range, then I takes on like integer values, right, in the range that you've specified. But when you do, in this case, just for I in, and then like the name of a list, then what you're doing is you're accessing every single element in that list itself. And this is good because I don't have to figure out what the length of 2D is, and it kind of results in something that's a bit cleaner looking, because if I were to use, say, an integer, then I'd also have to do something like 2D square bracket I square bracket to access what I want. But in this case, it's much simpler, and this is how you deep copy a 2D list. So yeah. So I'm gonna go by the assumption that you guys have not learned about nested for loops, and if you guys have, someone please speak up or stop me, unless like you guys want to hear the same lesson twice, which I mean maybe you want to, who knows. But now we're going to look at nested for loops. So nested for loops, I'm bringing this stuff up because they're tied pretty closely with actual 2D lists. Because when we look at the list comprehension for a 2D list, so we set 2D equal to, and then, I don't know, like k minus 1 for k in range 7. For j in range, we'll also do 7, I guess. And then we also always have to import pprint, because if you don't import pprint and you just do pprint.pprint, your program's not going to know what you want, because you actually have to import like this module before you can actually make use of it. You can't just make use of it without importing it, otherwise there'll be an error. Oh. Oh. Whoops. But yeah, so as you can see, this is our 2D list, and when we created it, it was kind of already a kind of nested for loop. So we know that a normal for loop is just like for, you know, k in range, we'll say 5, right? And then we have the colon, and then after that everything is like one indent further to the right. And then inside of this, we just like write the code that we want to be executed 5 times. So, you know, like maybe you want to print high 5 times. And yeah, you know, you print high 5 times. And here in this list comprehension, you kind of see the same structure. Like if you just ignore this highlighted stuff and you just pay attention to the stuff here, you're also doing like a for j in range, right? The only thing that's missing is like the colon, and you're also not really doing any like multiple line, you know, indented stuff. This is all just on one line. And you know, that's the great thing about list comprehension. It kind of saves space. But yeah, like as you can see here, in both of these list comprehensions, in the smaller one and in the bigger one, you do have like this for k in range kind of structure. So this is a 2D list, and when we have a nested for loop, you know, it's as simple as putting another for loop inside of this indented code. So like for L in range 6, and then here you can just print L to get an idea of like what the code is actually doing. So we don't exactly need the 2D list anymore to be printed, but if you just print L here and then you run the code, yeah, what you see is a series of numbers. So, well, a sequence of numbers. So we know that for L in range 6, whenever you declare a range with just an integer, it'll start at 0 and it'll go up to, but it won't actually reach the number that you put in that range. So you go from 0 all the way to 5. Now, the thing is, the actual printing of the L, it's instead of the usual like 1 indentation to the right, it's 2 indentations to the right, and if anything, there's like another for loop on top of the print statement, and then a second for loop. So you know, like 5 times 6 is 30, so it prints 30 numbers. But like the actual like the numbers that are actually printed and the order that they're printed in gives us basically tells us how a nested for loop runs. So first you go from 0 to 5, so that means it's running this inner for loop, and then once it finishes running from 0 to 5, then it starts all over again. And how many times does it like start over again? Well, it starts over, so it prints the numbers from 0 to 5. How many times? It prints, well, it prints 5 times. You know, like there's the first one, the second one, third one, fourth one, fifth one. So what we see here is that first the program runs this code, right, which is in and of itself a loop, and then this increment is increased, and then we run this code again, right? Then this increase. So like when I say it increments, I mean after you run this code for the first time, then k goes from 0 to 1, and then you run this code again. K goes from 1 to 2, and then on and on and on until eventually it crosses the range that it's in, so it stops running, and then in the course of that, you've done 30 things. So to make this clearer too, you could also print K to see like more of the order, I guess. And then you can also just do an empty print statement to get like I think a new line. Yeah, okay. So this should make it a bit clearer. So first, well, I mean, so technically you're running the code on the outside first, but then right after you run this code, then you go onto the inner for loop, right? So as you can see, I print K, so that means that this happens first, right? Or this chunk of code happens first, and then all of this code runs, right? And you get your numbers from 0 to 5. Then after that, the loop, loops, so you get this chunk of code again. Only, of course, K has incremented by 1, so now you get 1, which is what K is, the value of K, and then after that you get the numbers from 0 to 5, which is this inner loop running once again. So yeah, Python follows an order. So the code that you put into Python, it will run basically like from top to bottom, from left to right. So of course, this first loop that's not nested in anything, this is on top, so it goes from the top to the bottom, and then from left to right, which basically means this code runs. Well, I mean it's below this for loop, so yeah, I mean you can kind of ignore the left to right thing, but what that means is that indentation matters. So like if all of this was shifted like one indentation to the left, then you would no longer have a nested for loop, and that's a pretty important thing to remember, because that can kind of be maybe a bit confusing at times, and you just have to know that it's like putting one for loop at the same indentation under another for loop, like what we're doing here. That's not at all the same as a nested for loop, because here we're just going to print 11 numbers, right? It's like 5 plus 6, but when you indent this, you're going to end up printing 60 numbers, because first you run this code, then you run this loop, then this loops, and then you run this loop again. So yeah, and so if you see like this incorrect version, I guess we'll say, what you get is you get this first for loop running completely, being finished, and then this second for loop running, and it only runs once, instead of with the nested for loop, this inner for loop instead would have run 5 times, because it's inside or nested in a bigger for loop that has a range of 5, so it would have run 5 times. Yeah, so that's a nested for loop, and this stuff is also very important when it comes to computer science, especially when you want to like know all the different options that there can be. And there's a problem on DMOS called like old fishing hole. It's like a question about like you have to figure out all the different types of fish there, or all the different arrangements, and in that case using a nested for loop is really useful, because nested for loops in a relatively small amount of space can get you to run like a really large amount of different tasks. So yeah, now we're going to move on to the uses of nested for loops and also 2D lists, mainly 2D lists, right? Because 2D lists are more important. So if you guys have any questions, like please tell them to me, and or like I guess send a message on Discord. But other than that, there are these questions for you to try, and good luck with them, I guess. So I will post them in junior resources. Yeah, that's okay. So week 3 problems. I'll just paste all the problems that we, oh, well, this one. Oh, okay. So these are all the problems that you have. This first one is, this first problem is more about teaching you how to work with like moving through a 2D list. The second one is more about making use of nested for loops. This third one is once again about being comfortable with like moving through 2D lists, and this final one, this one's pretty difficult. It's like dynamic programming, and it's the problem wants you to figure out like what's the least number of moves it will take a knight to move to a certain different position on a chessboard, and that's definitely a more difficult question, but it also does involve 2D lists. And if you guys want to like maybe look ahead even, then if you can solve this problem, you're in a great spot because this is a pretty difficult question, and I only really like solved it properly kind of like last year, so when I was in grade 11. So it's definitely a pretty difficult problem, but you're always free to try it. And yeah,